With this, what we've had so far is a definite integral. And we have two constants. And we can go ahead and find that area under the curve. What happens, though, is that sometimes we want the integral to be a function of x. And so this upper limit would be a function of x. In this case, it just says x, but later on we'll get into some different functions to be there. And this f, not to confuse things, f has to be a different variable than this one here. So I need f of t dt, where this would be an x. Now what the second fundamental theorem of calculus says is that really if you take the derivative, if you take the antiderivative and then take the derivative again, you're going to end up with our same function back. So what I want to do is give you some problems here to try. I'm going to do the first one with you, and then you're going to try 1 through 4. So, and I'll come back to explain this one later, or I'll explain in class. So if I have this one, what this says is that I want to find g prime, given this integral. This upper limit is x. Let me show you how this is done. So if I want to find out what g of x is, I just take this integral and evaluate it. So what's the antiderivative of the sine, which would be negative cosine, and it is of t, and I'm going to evaluate this from 0 to x now. And so g of x, notice that this does say g of x, and so I'm going to end up with a function of x. So I take the x and plug it in. Don't forget to subtract and plug in the lower limit. A lot of times people forget to do that with the 0, but the 0 sometimes yields a number that's different than 0. And in fact, in this case, this would be a 1. So I'm going to get g of x is equal to negative cosine of x plus 1. Now what the instructions say, though, is find g prime. I kind of ran out of room here, so to find g prime, I take the derivative of this. Well, the derivative of the cosine is negative sine. With the negative there, I get the sine. So this would be the sine of x. What's the derivative of a constant? Derivative of a constant just goes away. So g prime is equal to sine of x. So now look at some patterns and see if you can figure this out. I want you to do 1 through 4 and see what you find out for g prime of x. Pause this and go ahead and do that. So now looking at this, I hope you did pause this and go ahead and try to do these the long way. Maybe after this one you stop doing it the long way, though, because you figured out the pattern. And I hope you did. What happens then is that whenever we look at this and take the derivative after we've taken the antiderivative, this constant, whatever we plug in there, will go away, because when I take the derivative of the constant, it disappears. So really all you're doing is you're taking this x and you're going to plug it into the function. That's all how you do this. And this is the second fundamental theorem of calculus. We're taking the derivative of the integral evaluated from a constant to a variable of some function. Take the x, plug it in. Boom, done. Wow, it's so easy. It does get more difficult, but let's see how this goes. If I do g prime of x here, what do you think? Well, just take the x, plug it in, and I'm going to get x. Done. Now, if you want to go ahead and do this the long way again, go ahead, please. Find the antiderivative of this, plug in these values, and then take the derivative again. You're going to get back to here. Now, here's an interesting example, because I alluded to this at the very beginning of this lesson. There's going to be some antiderivatives that we can't find. This is one of those cases. I don't know the antiderivative for this offhand. You can maybe find it on, what's that guy's name? Wolfram. But if I do want to find g prime, I can do that, though. I can circumvent all this by taking the derivative, take the x, put it right in there, and so g prime of x is going to be 1 plus x cubed. Done. Isn't that easy? Students really struggle with this, though. So the sooner you can understand this, the better off you are. Need to ask questions in class, please go ahead and do so you do understand this. Okay? Now, we need to go back and do this the long way, because now we have a function that's different than just plain x. So let's go ahead and try to do this one. So if I evaluate this one, remember that the antiderivative is negative cosine of t, and I'm evaluating from 0 to x squared. So g of x is equal to negative cosine x squared plus my 1 again. If I take the derivative, g prime of x, what happens now? Oh, wait a second. I am going to get the sine of x squared, but what else do we need to do? Well, I need to chain by this. So this is the only little nuance that we have to additionally put in. The constant will go away again. So I go g prime, yeah, I plug this in, but I also need to chain because my function is different. My function in my limit is different than just a plain x. So what are we chaining off? Well, this is the thing that we chain off, the upper limit, whatever function that is. So if I go ahead and do this one, let's do the shortcut way. Oh, I have to because I don't know the function here, or the antiderivative. So this would be 1 plus, take your function, plug it in, this would be the sine of x cubed. But what else do we need to do? Do I need to chain off by the sine of x cubed?